All right, so we're going to look at the bottom of this worksheet, and the first part of this is going to be a little easy. I'm going to kind of just put some answers on here because it's easy stuff I should be able to figure out. It's really the bottom of this page I want to focus on because it's probably been a little while since we've looked at exponential decay, so we're going to look at that at the bottom of the page. But looking at these first four, 12 and 13, focus on number 9. And honestly, this is a lot like a problem that he had on the beginning of the sheet with John and him getting $25 per cell, and he got 45 to figure it out. So I'm not gonna do the math. If you have a question on it, you can ask me. But he's gonna get 365 for 7 days, and then in 13, where we have to work backwards, your answer here was 11 hours. All right, so let's look at 14 and 15. 14 is asking about number 10, about how much money Jill is going to make in her savings account after 2 years. So if we look at the explicit function on that, it's going to be y equals 500, 1.12x. So this 2 represents your x, so you just got to plug that in right there. So we're going to have 500 times 1.12 squared. Pretty easy to plug into your calculator. We're going to get a final answer there of $627.70. All right, so the last one in number 15, this one takes a little bit more work to do. So it's saying that Bob is hoping to retire in 5 years, wants to know how much money is going to be in his IRA. So when we do this problem, so we have to start with the recursive rule. So he's got that 1,500 to start out. We have the rest of our function here where we're going to multiply that and then add to the 1,200. So we have to put this into our calculator a few times to get our answer here. So you did number 8, hopefully yesterday, a lot like a problem like this. You won't have to do it as much in this. So the first time that you plug it in, so after one of these, we get, it was 20, so the first time we do it, we're going to get 2,775. So we have to do this 5 more times. So your final answer should be 8,545 and 18 cents, somewhere in that area. So like I said, this is a lot like the problem that you did yesterday on number 8. So if you can work that one, then this one shouldn't be as too bad, just fewer numbers to work in this case. All right, so if we look at the bottom of this page, and this is, like I said, the page I really want to focus on because it's been a little while since we've done this. This is a lot like 6.4 in your book. You probably don't have your book, but you can look on the module 6 on 6.4 and kind of get the notes and kind of like refresh your memory on how to do that. So it tells us that the explicit function and the recursive rule for an old tennis ball with a bounce percentage of 65%, and we have a height here of 10 feet. So I'm actually going to start with the recursive rule because if you remember back on that section, we actually started with the recursive rule first. So our initial height, so I'm going to call this one H because we're talking about height, is going to be 10 because that's where we're going to start out at. So we're going to go H n plus 1 equals Hn, and then because this is going to be a exponential, we're going to be multiplying. So now the 65%, we need to change that into a whole number, which is going to be 0.65, which is what we get there. So there you go. There's your recursive rule, pretty easy. Explicit rule, also pretty easy. We're going to have y equals our starting point right here times 0.65, and then you have your x right there. So there you go. So those are the explicit and the recursive rule for that function there. So now it wants to know in number 7, where it's going to be at 2 inches. So if you remember how we do this, we have to go y equals, in your calculator, plug your explicit formula in. Once we have that plugged in, we're going to go second, and then look at the table. So when you end up doing that, we need something that's going to be below 2 inches. So all you have to do is look at your, in this case it's going to be y1, just find when it gets below 2 inches, and it's going to be on the 4th bounce that it does that. So on the 4th bounce, we get below 2 inches, and I'm actually going to show you on the graphing calculator what that looks like when you type it all in. Alright, so I have my function typed in here on the side, so I just went to y equals, typed everything in. I need to put my x right there. I don't know if it registered that or not. So we can go with our x right there. There we go. So now we have everything ready in our function. That's the one that we have for our explicit. So all we have to do is go second table, and we need our first y value that drops below 2. So if we follow that, it's right here. So that's going to be 4. So that's where we got our answer of 4 right here. So I'm going to write that out right here. So there you go. So the first time it drops below 2 is right there. The number that goes with it is 4. So 4 is your final answer right here for number 17. Alright, so our last problem here is number 18. So it's given a chart following the number of bounces and the corresponding heights. So we need to find 3 things here actually. We need to get the rebound percentage first, and after that we can go and write the explicit and then the recursive. So really the only tricky part about this is going to be getting your rebound percentage. So again, we did work one like this on 6.4, that very first chart. So if you remember how to get the rebound percentage, you take the height and then divide it by the height before it. So it was height divided by the height before, and this equals your rebound percentage. So all we have to do with our first one, we can't do our original one right here, but we can do this next one. So we're going to take the height after the first bounce and then divide that by the height before it. And the height before it in that case is 25. We're going to do that, and then one thing I want to add on here, we need to multiply by 100 because we're talking about a percentage. So when we multiply that by 100, we're going to get 87.5%. So that's going to be your rebound percentage. We can go and check with all of these. So we can go and take this, let me do a different color here. So I can go and take this and do the same thing. I'll do it right up here, the one before it. And when I divide this and multiply by 100, I'm going to get this same rebound percentage right here. So we just have to do it for one of them. It's going to be the same throughout. We're not going to have a super difficult problem where it's going to be where it'll give you different bounce percentages. That wouldn't honestly make sense, or rebound percentages. So that 87.5% is going to be your rebound percentage. So from there, we need to do our explicit and recursive rule, and then honestly, this part right here is a lot like number 16 that we just worked. So important thing to see here is that your initial height, or the original height, is going to be your 125. So I'm going to again do the recursive first. So I'll keep the same. So we got h of o is 125. So hn plus 1 equals hn. This time, sorry, not plus, we're going to be multiplying times this as a decimal, which is 87 or 875, and multiply it times that, and there it is. That's going to be our final answer, each of this right here, for our recursive rule. Last one is going to be the explicit. So got a lot of red going on here. I'm going to switch colors up and go with green right here. So we're going to have y equals, so we're going to start out with the initial, which is 125, multiply that times our 0.875, and then we got to make sure we put our x right there. So there's your explicit right there. So that's how you do number 18. A lot like number 16, like I said, it's just getting this rebound percentage, which is this formula right here, just taking the height and the height before it, multiplying by 100. So that's the end of review sheet. If you have any questions, please let me know, and we should be good there.